So we recently just finished talking about mathematics and counting and how that relates to addition. So counting is simply recognizing a difference and then applying that same logic over and over again. Addition kind of incorporates that particular type of thinking, which would be to say, well, in order to get the next number or representative value, the next count, going from 0 to 1, I then have to add. So it's this idea of I need to combine. And again, we see that in everyday life all over the place, whether it's liquids being added together or things being added together. But then we get to a weird operation known as subtraction. Subtraction seems to really confuse a lot of people. And that's because the main way that we're taught to subtract is to think about the idea of undoing our addition. So if I have 2, which was made up of 1 and 1, added together, then in order to go from that final number backwards, in order to reverse that operation, if I do 2 minus a 1, I get back to the original 1 that I started out with. And that is one way that you can think of doing subtraction. Another way to think about subtraction is the number line that we have. So in real life, you don't really ever have negative amounts of anything, do you? Just because someone might, owe some money, it doesn't mean that they contain a negative amount of money. The negative just represents the fact that that money is going in a different direction, right? If you owe someone money, then you are supposed to give it to them rather than taking it from them. So one of them would represent a gain and the other would represent a loss. So negatives and subtraction are the exact same thing. To do subtraction is the same thing as using a negative number. So you could literally rewrite all of mathematics just by simply saying that we only have the operation of addition. It's just that sometimes you can add negatives. You literally could rewrite all of mathematics to do that, but that sounds a lot more complicated to talk about adding, not only adding numbers in one direction, but adding numbers in another direction. So instead, to make it a little easier, we talk about negative numbers, numbers that are going in a different direction. And then to make the operations separate, we tend to think of addition and subtraction as being separate operations, even though in actuality, you're treating them the exact same way. A negative and a subtraction, those are the exact same thing. For example, 2 minus 3 plus 4 minus 5 plus 6. To consider what's going on here, I have 2 minus 3. So I could say it's 2, and then I'm subtracting 3. Or you could say it's 2 and a negative 3 and a positive 4 and a negative 5, right? You could, whether you call it negative or whether you call it subtraction or minus, it doesn't matter because they're the same thing. So a 2 minus 3 is negative 1. Or I could say a 2 plus a negative 3 is still minus 1. Then I add 4. So 4, if I say minus 1 plus 4, I'm subtracting a positive 1. I'm saying, okay, take one of these things and subtract it, and then add to that 4. So I've got one of these, but then I have it subtracted, and then I add 1, 2, 3, 4. So it should put me at a positive 3. All the way up to here is a positive 3. And I could just be satisfied with that, but to say a negative positive 1 value, right, subtracting a positive 1 value, that is the same thing as a negative 1 number. So whether you're considering negatives to be the negative number, like the entity in and of itself, or whether you're considering it to be, hey, subtract a positive value, right? Consider that all our numbers we deal with are positive and then subtract one of them, right? It doesn't matter which way that you're dealing with it because they are the same thing. You're dealing with the same operation, the same notation, right? The negative line, the little subtraction line, negative or positive, they are the same thing. So at this point, you have 2 minus 3, that's negative 1, plus 4, so that's a positive 3, minus 5, so a 3 minus 5 is a negative 2 at that point, and then plus 6 at the end of it is a positive 4. Another way you can do all of this is by the idea of grouping. So a lot of people like to group together the positive values. So this is a positive 2, a positive 4, and a positive 6. That adds up to 12. This is a negative 3 and a negative 5, which adds up to a negative 8. 12 combined with a negative 8 is the same thing as positive 4. 12 minus 8 is 4. And then likewise, 8 plus a 4 gets you back to 12. So there are so many different ways you can think about numbers and addition and subtraction, but this is just one of them. So the idea is here, representative of amounts, you have 1, 2, 3, 4, and so on. And then the direction they go is either one particular way or the other way, right? Negatives can be thought of as a different direction. Likewise, you could also think of all of this together as individual entities, that 1 and -1 are actually two symbols that are different from each other. So you could think of it that 1 represents some number, like you could think of x, and then -1, let's say that's y, right? You could represent the numbers that way as two totally different things altogether. Or, again, back to that first example that I gave, you could just think of 1, 2, 3, and 4 as being individual numbers, and then anytime that you subtract them, you're applying the subtract operator to it. So a subtract 1, it's still the same 1 value, it's just over here, right? So instead of having x and y, two totally different things, you would say, well, this is x, and then I have a subtract x over on the left-hand side. So anyways, that's just a different way that you can think about subtraction. Subtraction is a really helpful tool in problem solving. The reason why it's so hard, the reason why it's so difficult, is because you're starting out counting. To undo that, you have to think about it differently. No longer are you just saying, hey, add 1 to everything that comes up next. After 1, well, there's 2. After 2, well, there's 3. After 3, there's 4. I'm just adding 1 every time. Instead of that, subtraction then tells you to think of what you could have gotten as an answer, right? So if I was saying, 3 minus 1, I would have to say, well, think of what I could have gotten as an answer that would have been 3 from 1 and something else, right? So obviously it's a very easy example. 1 and 2 would give me 3. But the idea that, wait a second, we're kind of figuring it out in reverse tends to throw people off. It tends to be a little bit more of a complicated idea to undo those specific operations that just happened to cause something. So you're automatically, when you're doing subtraction, you're automatically invoking this problem-solving technique and method. So one of the ways that you'll see this come up a lot is from the fact that addition and multiplication are connected. You see, if I add 1 plus 1 plus 1, and I do a lot of repeated things like that, that's the same as 1 times 3. I added 1. How many 1s together? 3 of them. So that's the same as 1 times 3. Subtraction, and this is also another reason why people have so many problems with division, is because it's just connected to subtraction. If I say 6 divided by 3, that's saying, how many times can I subtract 3 from 6? And the answer is twice. You start with 6, you subtract 3, you get 3, you subtract 3 again, and you're at 0. Hooray, you've accounted for everything. So it's exactly 2. But that would be the equivalent of the subtraction problem in the same way that this is 1 plus 1 plus 1, and that's just 1 times 3. Or if I said 2 plus 2 plus 2 is the same as 2 times 3, this 6 divided by 3 is the same thing as saying, it's the same thing as asking the question of how many times did I subtract 3 from 6? Well, there's one of them here, one of them here. So the answer is 2. And this is why people tend to struggle with division a lot, because subtraction is directly connected to division, just like addition is directly connected to multiplication.